So as promised, here is the video on the sequences we did yesterday in class and at home. Okay, it's been worked by me time ago, a few years ago I'd say. I managed to scan all of it to make sure page 345 was actually present. So this is the complete scan I did yesterday after the lesson at school. So question number 1, the nth term of a sequence is that. The nth term of a different sequence is that. It's inevitable that there'll be some terms in each sequence where they'll be the same. You've got to find out 3 of these, and they've got to be in both sequences, and they've got to be between 20 and 40. All right, so not difficult. If you put in, say, 10 there, you've got 2 times 10 is 20 plus 1 is 21. Then just keep adding 2 each time because it's a 2n rule. So just keep adding 2, and you can stop when you get to 39 because we want a number between 20 and 40, or rather we want 3 numbers between 20 and 40. Do the same with the 3n minus 1. Let's have a look. I think I must have put 7 in there. 3 7s are 21. Take away 1 is 20. Then I just kept adding 3s because it's a 3n rule. So just keep going all the way. I mean, I could have put 41 there, but I would have gone outside the limits there. So you can see by comparing the 2 sets of terms for each sequence, 23 is common to both, 29 is common to both, 35 is common to both. There may be another way of doing this, but that's the, listing strategy is okay for grade 4/5. So there it is. There's your 3 numbers. Okay, so what's the next number in the sequence? It goes up plus 3. Some clever people would have written down, the nth term, didn't ask you to do that. What's the rule from continuing? To continue, you just add 3. You don't need a special term, an nth term for that. But there it is, 20, and then add 3, that's it. Now they're going to test you in question 2, a linear nth term. So let's go. Between 7 and 13, 13 and 19 goes up in plus 6s. So it's a 6n rule, tick, 1 mark. What number plus 6 gives you 7? 1, because 1 plus 6 is 7. So we have 6n plus 1, 2 marks. There was some debate over this one in class. First one of the tricky ones. It's definitely a Fibonacci type sequence. There's a sequence there. So we're told, for example, that 3 miles there is like going for the next number across and calling it 5 kilometers. That's pretty good. And 5 miles, if that was in miles, then that would be the same as 8 kilometers if you read in that direction. So change 13 miles into kilometers. Well, 13 miles, 21 kilometers. 13 kilometers into miles. Well, if these are kilometers, which is a small unit, you go back and get 8 miles. All right, it's easy. Use this pattern to change 42 miles into kilometers. Well, what I did was to take my 21 miles, which becomes 34 kilometers. So if you double up, that's 42 miles, which is what the question wants. Double up the 34, end up with 68 kilometers. I've shown the work in there for a couple of marks. I now want to use 2 values to change 18 miles to kilometers. Well, I cited 13 miles plus 5 miles in this sequence because 5 and 13 comes to 18 miles. Well, 13 miles will be 21 kilometers and 5 miles will be 8 kilometers. So 8 kilometers plus 21 kilometers comes to 29 kilometers. That's one way of doing it. Although in class I did it a different way because I was sort of thinking live. Okay, so here is a pattern made of grey and white squares. Work out the total number of squares in pattern 100. Please note it's not whites or greys, it's the total. So the first term, the first pattern has 6 blocks in it. The second one has 9 blocks, the third one has 12, etc. This is a slightly different colour to that because I wanted to highlight first pattern, second pattern, third, etc. And of course you need the 0 pattern to get the 0 term. So it goes up in plus 3s, hence the 3n rule. What number plus 3 makes 6? The answer is 3. So the rule is 3n plus 3. Now I can actually substitute 100 into that n and get 303. Complete this number machine for the sequence of patterns. Okay, so this is a relation between the greys and the whites. So 1 grey needs 5 whites around it, 2 greys need 8 whites around it, etc. So instead of messing up those diagrams there, I redid the pattern as shown. So greys 1, 2, 3, 4, which simulates this here, and then I just count the whites. 1 has got 5 whites, 2 greys requires 7. Is it 7 whites? 1, 2, 3, 4, 5. Yeah, it's 7 whites, not 8. Sorry, etc. So, and 4 greys are surrounded by 11 whites. As you can see, it goes up +2, +2, +2. So it's a 2n rule. What number +2 makes 5 for the 0 term? 3 does. So it's 2n + 3. So it's a lot of work for a mark, I have to say. So essentially, you take the number of greys, the n, you times it by 2, then you add on the 3. All right? Yeah, it's a lot of work for a mark. It's got to be worth 2 marks, though. But anyway. Question 5. Here's a quadratic sequence, half n squared. Which term is the first one to give us a value of greater than 50? Well, I know that 10 squared, which is the 10th term, will be 100 divided by 2 is bang on 50. So I'm wanting the 11th term, because 11 squared will be 121, and divide that by 2, and that's going to be 60.5. Yeah, that's greater than 50, all right? So a little bit of evidence gets 2 marks. Here is a different sequence. What's the nth term? Well, it's just straightforward linear. +3 all along, 3n. 4 + 3 makes 7, so the 0 term is 4. There it is, tick, tick, 2 marks. Sticks. Okay, so yeah, we did a couple of picture ones in class in the applications. In 21.3, I think it was, applications. Something like that, I can't remember. So anyway, yeah, don't be overawed by all these little matchsticks. You just say first pattern is 5, second pattern is 9, third pattern is 13, and as you can see, it goes up in 4s each time. So the 5th pattern will have 17 sticks. Add 4, 21. The 5th pattern will have 21 sticks. Just add them up, and that will come to 65, and you've proven it, because, or you've proved it rather, because you've got all the correct number of sticks for the first 5 patterns, and that's 2 marks. Okay, fine. Work out the nth term. It's, yeah, here we go. We have another. How does that relate to this, by the way? Does it? Don't know. Yes, it does. It does. It does. Look, 5, 9, 13, etc., etc. So the nth term is actually 4n + 1. Goes up in 4s each time. 4n. 1 + 4 makes 5. So the 0 term is 1. Completely works. 2 marks. Not sure what that blob is there. Oh, this gave amazing discussion. If you were listening to this one, I even sang a little song just to try and get somebody to hear it and see it. All right, so what's Jonathan doing? Counting shaded areas. Okay, so first pattern has got 4 squares, 2 grey shades. The second pattern has got 9 little squares, 4 of which are shaded, etc. Third pattern, we've got how many squares? 1, 2, 3, 4. I can't work this out. 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, 12. So, and 6 are shaded. Okay, I've got the picture. What's the question? John counts 162 shaded tiles. Now, I don't know if you've noticed, but I think we got the same number of greys as whites, but the greys is half the number of the total, I've noticed. So that's what I've listed here. So for pattern number 1, I've got 2 greys. Pattern number 2, I've got 4 greys. Pattern number 3, I've got 6 greys. Yeah, that's confirmed by the picture. So I'm generating a sequence. So clearly, pattern number times 2, actually it's just times 2 there, isn't it? Gives me the number total. So greys is 2 times the pattern number. And if John's got 162 grey tiles, sorry, if John's got 162 tiles around the edge, he's got half as many greys. So 162 divided by 2, he's looking at pattern number 81. And here's the question: how many tiles are along one side of the square? And here we go. Pattern number 1 has got a side of 2 squares. Pattern number 2 has got a side of 3 squares. Pattern number 3 has got a side of 4 squares. pattern number 4 has got a side of 5 squares. Pattern number n has got n plus 1 squares, okay? So if we talk about pattern number 81, that will have 81 plus 1 squares down the side, hence the answer is 82. Simple sequence, I just did that just to show my working. Got to get the first 3 terms of this quadratic sequence. Well, 1 squared is 1, take away 3 is minus 2, and just do the same for the other 2 and get a couple of marks. Don't know why that's not 3 marks, but anyway. This one's a bit weird, only a little bit weird. So a term-to-term rule for another sequence is as follows: times it by 2, then add 1. So whatever it is, times 2, add 1, and then that will generate the next term. Now apparently the second term is this algebraic expression. I've got to work out an expression for the first term. In other words, the term before that was generated. So the best way to do it is to do an inverse operation, come back along the flow diagram. It's a function, as you can see. So if we're coming back to the other way, then the inverse of plus 1 is minus 1, and then the inverse of times 2 is divided by 2. So I've got to take my 8x minus 5, subtract 1, and then divide by 2. So here's the setup. That's complete. That's a division line. It includes the minus 1. And so I get 8x minus 6, because minus 5 take away another 1 is minus 6. Then halve it. That gives us 4x minus 3. And there it is, 3 marks. Tricky. Comment on the statement. So Kim says t is always going to be greater than 1 because this term is always greater than 0. The answer is no, it's not. She's wrong, because if n equals 6, you end up with 6 minus 6 is 0, and 0 squared is 0, and 0 plus 1 is not greater than 1. And there's a lot of reasoning there for 1 mark, but the answer is she's wrong because of this reasoning here. Because who's to say n can't be worth 6? It says n's a positive integer. So in order to make this bracketed term 0, I have to go for n equals 6, and you're left with t equals 1, which is incidentally the answer to the next little bit. The only value of t that's a square number is 1. No matter what you put in n, when you take away 6 and square it and add 1, you will not get a square number. Question 10 is just finding the first 3 terms of this quadratic. Square the one, add 50, 51, etc. There they are. How many terms in the sequence are less than 100? Well, one way to do it is as follows. I know 7 times 7 is 49, and 49 plus 50 is 99, so I'm pretty close. Then I thought I'd try 8 squared, so I'm using trial improvement. So 64 plus 50 is 114, which is way over the top, I think. So how many of these terms are less than 100? Well, there's the first one, there's the second one, there's the third one, and there's the 7th one. So 7 of these are under 100. What's next? Okay, so just follow the pattern. Keep adding 2. There's your 14 there. And how do you get from 14 to here? Well, 7. Then the 8s are missed out, so 9. I want 2 jumps to go from 7 to 9 and 14 to 18. 14 plus 2 is 16, plus 2 is 18. And if that was 5, then it goes 6, 7. And then what? Okay, I've got from 18 to 24, I've got 3 jumps of 2. So I want 3 jumps from 9 up to 12. I want 3 jumps from 9 up to 12, and 3 jumps from 7, 8, 9, 10. Is that alright? You sort of use the pattern test to fill in the missing bit, and it's all based upon this plus 2 here, and unless you see that, then obviously you can't make progress. And you don't have to work it out because the answer is 24. Geometric sequence. The only one that's geometric is this one. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. The common ratio is 1 to 2. The others, I didn't bother to look at that because they don't work. This is a beautiful piece of algebra, it's lovely. The new sequence is formed by squaring each of these terms of this linear sequence and then adding 1. Okay, really? Okay, let's make a new sequence. So I square each of those and then add 1. Well, they want algebra, don't they? So I'm going to take the rule, which is why they've given it to us. I'm going to square that, then plus 1. So I get a mark for setting it up correctly. You multiply out, 5n minus 1 with 5n minus 1 alongside each other, and you can do this. It's that. I didn't show the thing written out twice, it's just not worth the 4 marks. But it's worth it for you if you can't see it in your head. So anyway, 5n minus 3 squared is that, and don't forget to add the 1. And that simplifies to 10, factor out of 5. You've now proven algebraically that everything in the new sequence is a multiple of 5. Is that right? It's 5 of this quadratic sequence. And that's beautiful. 4 marks, well deserved. Then there's this awkward brick question. Awkward brick question. So these are the size of bricks in inches, 8.5 inches, 2.5 inches tall, and 4-inch brick of depth of 4 inches. So they're all going to build a wall out of that. And of course you can't build a wall unless you have a mixture of sand and cement to make the mortar. That's like the glue that keeps it together. So that's the story. Now it's crashed. Yeah, it's crashed. No, we're back. There's the wall. They've drawn us a lovely wall. They've gone 1, 2, 3, 4, 5 layers deep. Don't know if that's relevant yet. Mortar is the glue, like I said, a mixture of sand and cement in appropriate proportions. If it's too sandy, the wall just collapses because there's not enough to make a sufficient binding effect with the cement. And you never just use straight cement. I don't know why. Talk to a builder. Anyway, there's the wall. Each brick 2.5 inches. The width of each brick is 4. The length of each brick is 8.5. Now this is quite tricky. There's a lot of numbers here. Now there's my first answer. I've got to prove that the thickness of the mortar between the bricks is half an inch. So I'll try and show that in one go. There it is. Now look, I know that the length from here to here is identical to the length from here to here. After all, it is a well-constructed wall. So I'm going to set up an equation. 4 plus 8.5 plus 8.5 plus 8.5 plus 4 plus 1, 2, 3, 4 unknown thicknesses of mortar should make 8.5 plus 8.5 plus 8.5 plus 8.5 plus 3 unknown thicknesses of mortar. I've verbalized the equation. Now it does say show that the mortar is 0.5 inches thick. That would imply setting up an equation and arriving at the answer of 0.5 rather than using 0.5 and just putting it into the wall and showing that these two lengths are the same. It's correct, but I would go with algebra. It's a higher level thing. So I've got 4 lots of 8.5 underneath here, there it is, plus 3 lots of x, and that's the same as 3 lots of 8.5 plus 4 and 4, 8, plus 4 lots of mortar. Is that right? That's the algebra. Now you tidy this up, simplify it, get the x's to one side, you will find that x is worth 0.5 of an inch. There it is. I'm just going to leave it there. You can pause the video and meditate and think deeply about it, which is what meditate means. It means to think things over, chew it over, come back to it again, think again. Meditation is exactly that. So there it is. Thinking deeply about stuff and applying it. So we're applying these measurements to this wall, and we've proven that the mortar, the glue, is half an inch thick. The plot thickens. Now the plan view of the wall is you standing right here, there, and looking down that space, so you can see all the edge here plus the empty gaps down there. It's not a solid wall. There's a gap of about whatever across there, and I think they want us to work out the whatever. Let's take a look. Yeah, they want us to work out the distance between the inner empty space of the wall. So I began to think, well, that's 4 thick, that is half an inch thick because it's got mortar, and that's 8.5 inches long. Altogether it comes to 13 inches. So if the distance from here to here is 13 inches, I simply have to take away 2 brick widths, which is 2 fours, and end up with a 5-inch gap. All right. Front elevation. That just means look at the front of the wall they built us. So we're looking at this part over here. So at the front then we're looking at this. Work out H. Okay, that's quite easy. I know each brick is 2.5 inches tall, and I know I've got 1, 2, 3 rows of mortar to keep the 4 bricks stuck together going right the way across the wall. So I've got 4 lots of 2.5 plus 3 lots of 0.5, half an inch of mortar, comes to 11.5 inches high. Done. The front elevation of the wall has n rows. Okay, that's great. So they're not telling us how many rows I've got. I've got to work out n now. I'll work out my answer in terms of n. Right. I don't know how many rows I've got. Here I multiply by 2.5 by 4 because I can see 4 rows. But I don't know how many rows I've got. So it's going to be 2.5 times n, not 2.5 times 4. That's where that came from. Now, how many rows of mortar will I have for n rows? Well, can you see for 4 rows, I've got 3 rows of mortar. So for n rows, I must have 1 less, because obviously the top and the bottom don't have any glue on top and underneath, because it's just not there. You want rows of mortar in between the layers of bricks. So if I've got, say, it's 10 bricks tall, I'm going to have 9 layers of mortar. All right. Here, if I've got 4 bricks high rather than tall, I've got 3 layers of mortar. If I've got n rows across, I must have n minus 1. All right, there's 1 less. So here it is. I've got 2.5 n's plus ½ inch times n minus 1. Don't leave it like that. Multiply it out and simplify it. So the final answer will be 3n minus ½ an inch. That is the expression for the height of a wall of n rows. Right? That's it. What's next? And here's your grade 7 quadratic. Again, you're really brilliant at this in class, and so let's just go through it. It's the last question. So okay, it's a quadratic sequence. Hint, so the first level differences goes up +4 +6 +8. No help, but I can see at the second level it goes +2 +2 +2. So it's not even like a 4n squared rule, it's just a straight n squared rule, which is easy. So then, like I told you in class, again, you've got a page to do this. You write out the sequence again, the original, and take away the n squared component. Well, the first term is 1, 1 squared is 1. The second term is 2, square it is 4. 3 squared is 9, etc. So I did the whole lot. And then you subtract it. By subtracting, you remove from the final quadratic sequence the quadratic part of it to be left with a linear sequence. All right? So then you get both components. So by subtraction, I got 10, 11, 12, 13, 24. I didn't really need all this, but just for teaching purposes. So from 10 to 11 is 1. From 11 to 12 plus 1. 12 to 13 is plus 1. So I know it's a plus 1n rule. Now, again, got to get the 0 term. What number plus 1 makes 10? Answer 9. So the rule for that linear sequence is n plus 9. Now, put it all together. N squared plus n plus 9. Boom, there it is. How many marks did we get? 4. Yeah, well deserved. And there's your grade 7. I'll rate it as grade 7 anyway. Quadratic sequence. Is that all right? Well, that's nice. I think we're done. And I'll see you in class next week. Don't forget to study this video.